All right, here we're at 2018 now. Question number 1. The manager of a grocery store selected a random sample of 11 customers to investigate the relationship between the number of customers in a checkout line and the time to finish checkout. As soon as the selected customer entered the end of a checkout line, data were collected on the number of customers in line who were in front of the selected customer and the time in seconds until the selected customer was finished with the checkout. The data are shown in the following scatter plot along with the corresponding least squares regression line and computer output. Part A, identify and interpret in context the estimate of the intercept of the least squares regression line. The intercept is the constant 72.95. That's identifying it. Interpreting in context means use it in a sentence. So on average, so this is the constant. So that would be right. This is the intercept. This is this value right there. Actually, scratch that. It's that value right there. Value at 0. So if there are no people in line in front of you, we estimate it would take 72.95 seconds to check out. So let's write that down. If no one in line in front of you we estimate 72.95 seconds to check out. B. Identify and interpret in context the coefficient of determination, r squared. Alright, so the coefficient of determination is r squared, is that. There's our identification. Interpreting in context, so this is the amount of variation explained by amount of variation in the time that it takes to check out that's explained by the linear relationship or explained by differences in the number of customers in line. The other 20, right, so most, essentially, if you're always getting in the shortest line, you're probably, like, not 73.33% of the time, but, like, this is a major factor, the major factor in how long it takes you to check out. So, r squared equals 73.33. 73.33% of differences in checkout time are explained by differences in number of people in line. And C. One of the data points was determined to be an outlier. Circle the point on the scatter plot and explain why it is an outlier. It's obviously this one. And why it's an outlier. So what's weird about it, it's well below the line. It's the one farthest away from the pattern. To put it more into context, which it doesn't ask for here, but is still a good thing. Okay, so that's the point The person checked out significantly faster than you would expect for a person with three people ahead of them in line. And we circle it on the scatter plot itself. So that's that.